Hi, this is Miss Park. Today's video is going to be a review of trigonometry from grade 10. So what you're looking at is two right angle triangles, and I cut these right angle triangles in a very careful way. So I started with this one here, and then I made another one where each side length is double, 2 times the side length of the smaller one, right? So if this side length was x and this was y, then this side length is 2x and this is 2y, right? And then the hypotenuse will also end up being twice the hypotenuse of this one. When we have this situation, these triangles are called similar. They're similar triangles. Similar triangles, or similar shapes in general, have the same shape. So to get the same shape, we have to have all of the angles equal. So they both have 90 degrees. And I cut this so that my angle here in the corner is the same, and also more or less close enough because I'm cutting by hand, but my angle up here is the same. And so if I have two triangles where all their angles are the same, they're called similar, and then this will be true about their side lengths. Okay, the ratio between the side lengths is always going to be the same. So times 2 times 2 times 2, okay, the same. Here I cut another one that is approximately 1.5 times the small one, and I can actually put them one on top of the other like this. Just line them up, and I get this kind of formation, okay? Now, since they're all similar, then, and the ratios are the same, this leads us to something called trigonometry, which is we'll use the fact that the ratios are the same, regardless of how long the sides are, the ratios are always going to be the same, to figure out sides and angles that we don't know. Okay, so trigonometry comes from this concept of similar triangles. So I'm going to take you to your booklet. This is the first page in your booklet, and we're going to do a little bit of a recap of trigonometry from grade 10. So we're going to start with only right angle triangles, okay? We have a relationship called the Pythagorean Theorem. So this was first taught to us in grade 8. And Pythagorean Theorem says this: if I take this triangle ABC and I label the sides little a, little b, and little c, so across from big A, I put a little a. Across from big B, I put a little b. Across from big C, I put a little c. Then there's a relationship that says that a squared plus b squared equals c squared. So that's the first thing that we're going to use in trigonometry. We're going to use this relationship. The second thing we learned in grade 10 is that, remember how all of these, the ratios of the sides of these triangles, they're all the same, right? Regardless of the size of the triangle. Well, those ratios have names. So let's look at over here. It's talking about angle A. This is angle A, all right? And if I take from angle A and I label the sides, so I have little a is across from big A. Being across on the other side of the triangle is called the opposite. So that is the opposite side. Little b is right beside A. So being right beside is adjacent. So in English, the word adjacent means beside, right? Sitting beside someone, so you're sitting adjacent to someone. Now this little c is across from the 90 degrees. It has a name called the hypotenuse. All right. And then last year we defined 3 trigonometric ratios: sine, cosine, and tangent. Okay, so we read them like this: sine, cosine, and tangent. All right, and they were defined this way: the sine of angle A is equal to the ratio between the opposite and hypotenuse. So you divide the opposite by the hypotenuse. So if I use the letters in this triangle, so that would be little a divided by little c. The cosine is defined as the adjacent divided by the hypotenuse. So little b over little c. And the tangent is the opposite divided by the adjacent, which is little a over little b. Let's look at the triangles from the beginning. Okay, let's look at these triangles that we had. Okay, this little triangle. Suppose this is angle A down here. Okay, so here's my hypotenuse. So we would say that the cosine of this angle A is the adjacent over the hypotenuse, so x over hypotenuse. The sine is the opposite over the hypotenuse, so y over the hypotenuse. And the tangent is opposite over adjacent, so y over x. But if I did the same thing with this triangle, and here's my angle A, right? Each of these sides is 2 times these sides. If I find the sine, the cosine, and the tangent, they're all going to be fractions that reduce to the same values as here. So that's why, so 2y over 2x is the same as y over x. So that's why it doesn't matter the lengths, it only matters how these compare to each other. Okay, and that's the basis of the trigonometry. Okay, in grade 11, we have 3 new ratios, and they're called reciprocal trig ratios. Okay, and this is what they're called. The first one is called cosecant. It looks like this, CSC. Okay, and cosecant of A is the reciprocal of sine of A. Reciprocal, just like that. So let me write the word cosecant. Okay, cosecant of A is the reciprocal of sine. So it is the hypotenuse over the opposite. Reciprocal. Okay. The next one is called secant. Secant of A is the reciprocal of cosine. So that's going to be the hypotenuse over the adjacent. So let me write that here, secant. And the third one is cotangent. Cotangent of A is the reciprocal of tangent. Reciprocal of tan A, which is going to be adjacent divided by the opposite. Okay, so those are your reciprocal trig ratios, cotangent. And I'm going to write that this is new in grade 11. So everything else in today's video is grade 10 with the exception of this. This was the only thing that's new. Okay, so how do you evaluate these things with the calculator? So sine, cos, and tan are functions that act on the angle. So the first thing it says here, make sure your calculator is in degree mode. Okay, calculators are different, and there's different ways of changing the mode. Some calculators have a button called DRG. Let me write that over here. DRG. DRG button converts between degrees, radians, and grads. Degrees, radians, and grads are different ways that you can name angles, or you can measure angles. For us, in grade 11, we're using only degrees. And in grade 12, you'll use radians. But for now, we need to make sure that the calculator knows that we're using degrees. On my calculator, it's a matter of pressing the mode button and changing the mode, pressing it a few times until I see degrees, radians, and grads. And then I will choose one. And if I look really, really closely, that's a D. So at the top of your calculator, you should see on the display either a D or a DEG, which means degrees. If you don't, it means you need to find some way on your calculator to change the mode. Okay. Okay, so now, if your calculator is in the right mode, you can type in, you can find your trig function. So here's my sine, cos, tan, and I go cosine, 60 degrees is 0.5. So all this is saying is fill it in. What do you get with your calculator? If you type in 60 degrees, you get 0.5. Okay, now there was another thing we learned last year. Last year, What if you don't know the angle, so you don't know what to type in the calculator, right? But you know that the cosine is 0.5. How do I get my calculator to tell me, oh, that was 60 degrees? Right? So what we did last year is we used something that we didn't really know what it was last year, but we do now. We did the inverse. So what is the inverse of cosine? Well, the inverse of cosine is called cosine inverse. And it is a button on your calculator. So we're going to undo the cosine on both sides. So undoing it on this side gives me theta. Oh, sorry, I should tell you what this is. This thing here is called theta. It's a Greek letter, and it means just means we use it for missing angles. Okay, we just use it for missing angles. You can call it x, you can call it a, it doesn't matter. Okay, so to find theta, I have to undo the cosine here, but that means I also have to apply the inverse function here. On your calculator, if you press shift or second function and then cosine, you will get cosine inverse, and then you can put in, I like to open brackets, depends on your calculator, but some calculators give you the brackets automatically, and I push that in, I get 60 degrees. Now I only got 60 degrees because my calculator is in the right mode. It's in degree mode. So it's really important. Okay. Solving a right triangle means finding all the missing sides and angles. Okay. This triangle well, there's always going to be this 90, but this triangle here has a one side length is given 10, the other one is given as 8. I need to find all the others. So let's label them A, B, C. You can put the letters wherever you want. Here's little a, here's little c, and here's little b. First thing I notice is I have two sides, so to get the third side, the easiest thing I could do is apply the Pythagorean theorem. So Pythagorean theorem says little a squared plus little b squared is little c squared. Little a squared is what I'm trying to find, plus 8 squared equals 10 squared. Now I can solve for this. Little a squared plus 64 equals 100. A squared is 36, so a is 6. So now I know that a is 6. Okay, now so I got all the sides now. So now I need to find the angles. And to find the angles, I have no information from inside the triangle. I must use the side length. So I will label the triangle. So for angle A, so if, let's say I want to find angle A. For angle A, this one's the opposite, this one's the adjacent, and this one is the hypotenuse. So I can pick which one I want to work with. So the way we do it is we use a little memory aid that looks like this, SOHCAHTOA. SOHCAHTOA, and it means sine is equal to opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. It helps us to remember what they all are. So if I want to find angle A, I actually have all three sides because I found little a first, but we don't usually we just have two sides. So let me just work with the two sides that I have. I have the adjacent and I have the hypotenuse. So if I have the adjacent and hypotenuse, which of these, sine, cosine, or tan, would be helpful? Right? So you look at it, you go, well, sine needs opposite and hypotenuse. Cosine is the one that has adjacent and hypotenuse. This one has opposite and adjacent. So remember, we do have the opposite because we just found it, but it's not usually that simple. So I'm going to use cosine. So I write it like this. I go cosine of A is equal to adjacent over hypotenuse. So cosine of A is equal to 8 over 10. So A is equal to inverse cosine of 8 over 10, right? When we're finding the angle, we have to inverse cosine to undo this cosine and get the angle alone. That's how to isolate the angle. So now into my calculator, all in one step, I go inverse cosine. I'm going to open a bracket, 8 divided by 10. And I get about 37 degrees. So approximately 37 degrees. Right? Now I can use trigonometry also for the last angle, but noticing that I have two angles already, the last one is probably easiest if we can just use the fact that all of the angles have to add up to 180 degrees. So angle B is 180 degrees minus angle C. Let's go like this. Angle B is 180 degrees minus angle C minus angle A. Okay, and that's 180 degrees minus 90 degrees minus 37 degrees. And if you put that in the calculator, you get 53 degrees. So now we've solved the triangle because we found all of the missing sides and angles. All right, let's do the next one. Given the value of one trig ratio, find the values of the other two. This is super important for our unit. I'm going to put here important. And I can do this without a calculator. All right, so it says, if you know that tan theta is 5/12, what are sine theta and cos theta? And actually, because we're in grade 11, I'm going to ask for all 5 trig ratios. So that means the sine and cos, and then also the 3 reciprocal ratios that are new in grade 11. So all you do is you draw the triangle. Okay, let's put theta over here. Tan is 5/12, so the 5 is the opposite and the 12 is the adjacent because tan is opposite divided by adjacent. So I'll put my 5 here and my 12 here. And my 12 here. Now to find sine, so let me write SOHCAHTOA again over here. So I know that my sine is going to be opposite over hypotenuse, right? But I don't have hypotenuse. So we find hypotenuse. Okay, so 5 squared plus 12 squared, how much is that? It's 169. So to take the square root of that, you get 13. So the hypotenuse is 13. So sine is going to be 5/13. Sine of theta. Cosine of theta is adjacent over hypotenuse, which is 12/13. And now I have the other two. So I got my tan, my sine, and my cos. Let's find the other 3. So cosecant theta is going to be the reciprocal of sine. So that's just 13/5, reciprocal of this. Secant theta is reciprocal of cosine. So that's just 13/12. And cotangent theta is reciprocal of tangent, which we know, so that's 12/5. All right, and so that takes care of everything you need to know for right angle triangles, right? We're just gonna continue. I guess it's a long video, but we have, this is several weeks of learning of grade 10, which we're doing in one video. So here's the thing, if you don't have a right angle triangle, okay, here's my right angle triangle. Not all triangles are right angled. Let's look at this one. So if you have a triangle that's not a right angle triangle, we have something called the sine law. Okay, the sine law. This is the sine law. You use it when it's not a right angle triangle. Okay, and the proof is over here. You can have a look at it, see if you're ready to try and understand the proof. But I'm just going to go through how to use it. Okay, so the sine law says this. I don't have a right angle triangle, so I don't have opposite, adjacent, and hypotenuse and those kinds of things. But there is a relationship between the angle and the side across from it in every triangle. So the sine law says that the sine of angle A divided by the side length little a, right, these two are across from each other, is going to equal the sine of angle B divided by the side length across from it. And that's also equal to the sine of angle C divided by the side length that's across from it. So in this example, it's saying solve the triangle. So remember, solve the triangle means find all the missing things, right? So I'm going to start with the easiest thing, which is finding angle C. That's 180 degrees minus angle A. minus angle B. And if I put that in the calculator, 71.2 minus 63.7, I get about 45 degrees, so 45.1 degrees. Okay, so that's going to be my angle C. I can actually write it in here. Good. All right, now I want to find the side length. So let me start with little b. So little b goes, okay, so the sine of angle A over little a is equal to the sine of angle B over little b. Now I'm going to put in all the things that I have. So sine of 71.2 degrees over 75 equals sine of 63.7 degrees over little b. Okay, now how do I get little b? It's in the denominator. How do I get it out of there? Okay, so how we get it out of there is we clear the fractions. We multiply this equation by 75 and by b so that things will reduce on both sides. So if I multiply both sides of the equation by b, I'm going to get b sine 71.2 degrees over 75 equals sine 63.7 degrees. And now to get the 75 out of there, multiply both sides by 75. So I have b sine 71.2 equals 75 times sine 63.7. And then to isolate the b, this is just a number. This is also just a number. 75 sine 63.7 degrees over sine 71.2 degrees. Into the calculator it goes, all at once. So it goes like this, 75 sine 63.7 divided by sine 71.2. And I get B is 71 centimeters. Okay, so 71 centimeters. Now, you might be looking at all my steps and go, I don't remember this from last year. Yeah, because what I really did is showing you why something works. Last year, what we did is we said you cross multiply. B times this equals 75 times this. So all I did was I threw in an extra step to show why that works, because here it is. Here's the cross multiplication. And the reason it works is because we are clearing the fractions. We're multiplying both sides by the denominators to get rid of both denominators so that they cancel on the other side. Okay, so for finding angle C, I'll use the cross multiply. I'll skip that step. So I'll go sine A over A equals sine C over C. And so sine 71.2 degrees over 75 equals sine 45.1, that was the one we found, over little c. Cross multiply, c sine 71.2 degrees equals 75 sine 45.1 degrees. Divide both sides by this number, 75 sine 45.1 degrees over sine 71.2 degrees. And that right in the calculator, all in one line, 75 sine 45.1 divided by sine 71.2, about 56.1. Okay, and so there you have the sine law. And the last thing to remind you of, or to teach you for the first time, whatever the case may be, is when you look at the sine law and you're putting in all these numbers, the thing you're looking for is there's one unknown, but the other three are there, right? You can only solve this equation for b if you have all three numbers. So what that means is you must have one fraction that's complete. It has both numbers in it. It means you must have an angle and the side across from it given to you. Because if you don't have that matching pair, you would have another variable on this side, and then you can't solve for the b. Right? So we must have a matching pair given to us. Sometimes we don't. So let's look at this example here. We don't have a matching pair. I don't have the little b that goes with 39. I don't have the angle that goes with the 42. I don't have the angle that goes with the 51. So in the case of the sine law not working, we'll use the cosine law. So when do you use the cosine law? When we don't have a matching pair of angle and opposite side. Or in other words, when you can't use a sine law. When you can't use a sine law, you use the cosine law. All right, so let's use the cosine law. So the cosine law has a formula that looks similar to the Pythagorean theorem. It looks like that, but then there's some stuff subtracted away. So this one again says solve the triangle. So I'm going to start with solving for little b. Okay, look at the formula carefully. Notice that whatever letter you start with in the formula for the side, you've got the matching letter of the angle at the end of the formula, and then the other letters in between. So that's how you will remember it. So a squared equals b squared plus c squared minus 2bc cos a. This one and this one matches, and we're going to have different flavors of the formula depending on which side we're solving for. So if I'm going to solve for side little b, I'm going to start with the formula that starts with little b squared. And I know that at the end, I'm going to end up with cosine big B. So without looking at the formula so much, I can say, well, it looks like Pythagorean theorem, so it's something like this. But then here's the part we have to remember. Minus 2, this one times this one, cos B. Okay, so important thing is you start and end with the same letter. So here's my little b. Little a squared, so this is little a and this is little c. This is 51 squared plus 42 squared minus 2 times 51 times 42 cosine of 39 degrees. And that's little b squared. Okay, there we go. In the calculator, all at once, 51 squared plus 42 squared minus 2 times 51 times 42 times cos 39. 1035.7. Okay, now if you look at this triangle, 42, 51, can this be 1,000? No, it's not going to be 1,000 because that's b squared. So to find the b, I want to take the square root of this. So I'm going to find my square root button, and my calculator has an answer button, which will bring back the previous thing that you put in, the previous answer that it found. So I'm going to say answer. Square root of my answer is 32.2 approximately. And that's a little more reasonable. Okay, so notice that by putting things in the calculator in one line and never writing down stuff and typing it back in, I'm actually keeping my answers as accurate as possible. If I wrote this down and then typed it back in the calculator to find the square root, if I said square root of this, I would actually have a slightly different number. So this is 32.18, but if I just went like this, square root of 1035.7, okay, it just so happens. It's the same, but it doesn't usually happen. Okay, anyway. Keep stuff in the calculator. Try not to write it and put it back in. Okay, so there's our little b, and now I need to find little c. Now I have, by finding little b, I now have an angle and an opposite side pair given to me. All right. I can use the cosine law again if I wanted to, but problem is I don't have the angle across from 42, so it'd be hard to set that up. So now that I have this pair, I should be using the sine law because that's what you do when you have a pair given to you. So now I'm going to say sine of little b. Oh, sorry. And what I want to do now, no, I don't want to find C. I want to find angle C. That's what I want. I want to find angle C now because I have all three sides. I need to find these two angles. Okay, and I can find angle C using the cosine law because I have little c given to me, but easier is to use the sine law because I've got this pair. So I'll go sine big B over little b equals sine big C over little c. Okay, and so sine big B is sine 39 degrees over 32.2 equals sine, I don't know, sine C over 42. All right, now we want to isolate the C. Cross multiply. So I'm going to get 32.2 sine C equals 42 sine 39. And the sine C is one piece, it's one object. So we have to isolate sine C. Sine C is equal to 42 sine 39 over 32.2. And now I need to get C alone. So to get C alone, I have to apply the inverse of sine, right? I have to unsine. So C is going to be the sine inverse of all this stuff in the bracket. 42 sine 39, 42 sine 39 over 32.2. Okay, and you can put all of that into the calculator at once if you want to. I'm actually going to use the answer button. So I go 42 sine 39 divided by 32.2 is this much. And now I'm going to go shift sine of my answer, and I'll get 55.2 degrees. So C is approximately 55.2 degrees. Okay, last thing I need to find is angle A, right? I don't need to go through all of this processes to find angle A because I can use the fact that they all add up to 180. And I get 85.8 degrees. Okay, so now I've got all of them and I've solved the triangle, okay, using the cosine law. So those are the things you need to move forward in our course, okay? There's practice on the next page. These are sort of harder ones where you have two triangles. There's practice with sine law and cosine law and SOHCAHTOA on this next page. Okay, and the answers are provided on the page after that. There's also some word problems. Okay, so do that practice kind of throughout the unit. And if you need to watch this video again, feel free to do that. Okay, thank you for watching.